Alright, our notes for today are over transformations of sine and cosine graphs. Our essential question is, how do we graph the transformation of a sine or cosine graph using the amplitude, period, phase shift, and vertical shift? We're going to jump right into our first example. We want to state the amplitude, period, phase shift, and vertical shift for f of x equals 4 times the cosine of x divided by 2 plus pi minus 6. And then once we've done that, we want to graph the function. So the first thing I want you to recall from the notes that you took previously is that we have this general form of our equation: y is equal to a times the cosine of bx minus c plus d. And the first thing we want to do is to label all of our parts. What are our a, b, c, and d from our original equation? So our a value is the number that's in the front, our coefficient. So our a is 4. Our b is the number that's being multiplied by the x. So our b is 1/2. C is the number that's being subtracted from the x term inside the parentheses. So I want to do the opposite. You know, the formula says minus c, so I want to do the opposite of pi, so c is going to be the opposite of pi, or negative pi. And then d is the number being added or subtracted at the end, so our d number is negative 6. Now, once I've filled those in, now I'm ready to fill in my amplitude, period, phase shift, and vertical shift. So my amplitude is the absolute value of a, the absolute value of 4, which is equal to positive 4. So our amplitude of our graph is going to reach a height of 4. Period. 2 pi divided by b. So we're going to take our 2 pi. Remember, 2 pi is the period of the parent function, cosine. And we're going to take 2 pi and divide by b. So 2 pi divided by 1/2, which can be rewritten as 2 pi. Remember, when I divide by a fraction, that's the same as multiplying by the reciprocal, so it's 2 pi times 2 over 1, which becomes 4 pi. So the period of our new function, 4 times the cosine of x divided by 2 plus pi minus 6, is going to have a period of 4 pi. We'll take that entire length to make it through the entire cosine graph. Phase shift, c divided by b. We're going to take our c number, which is the opposite of pi. We're going to divide by our b number, which is 1/2. So again, going to employ division of fractions. Got the opposite of pi times the reciprocal of 1/2, which is 2 over 1. Negative pi times 2 over 1 is negative 2 pi. This is our phase shift. And then finally our vertical shift is the d number. Our vertical shift is going to be negative 6, which means we will be shifting down 6. Also remember that the d number is also where our midline is located. So our midline is going to be located at y equals negative 6. Now that midline is very important as we go about drawing the graph. Let's go ahead and pause. Make sure you have all this information copied down, and we will start the graphing. Okay, for the graph, remember that our cosine parent function looks like this little chalice format. It takes 2 pi for the entire cosine period to be implemented. Starts high, goes low, ends high. Takes 2 pi to finish that. On our graph, it's going to take 4 pi to finish that entire shape. So what I'm going to do is on my graph, I'm going to make sure that it reaches to a length of 4 pi. I'm going to go ahead and mark that on my graph. When I'm drawing my own, I just go find where that is and I mark it. If I'm using something that they've already provided, I find where it is on their particular graph. But when you're drawing your own, just kind of figure out where you want 4 pi to be. And then from there, I'm going to break this into 4 little sections, because when we did our parent graphs previously, it was always broken into 4 sections. So first section I'm going to create is the one that's exactly halfway. Notice on our graph we have that point where it's exactly halfway. When it's at its lowest point, that's where I want to have my middle value. That's going to be at 2 pi. And then I take each one of those sections and I cut them in half as well. And this one is at pi, and the other one is at 3 pi. Okay, so I took my graph, I divided it into 4 sections. The next thing I'm going to do is I'm going to draw my midline. So start by dividing it into 4 sections. Now figure out where your midline is. Midline is at -6 for y. So I'm going to go down to -6. I'm going to count by 2's, just so it doesn't take forever to get there. So -6 is located there. And once I have where my midline is, I'm going to start figuring out where my points are. Now this is a cosine graph, so it starts on the y-axis. It's going to start whatever the amplitude is above the midline. So my amplitude is 4, so if this is my midline at -6, go ahead and draw that little dotted line in there to represent it. I want my graph to start 4 above that. So I'm going to go to where the -6 is. I'm going to go up 4, which will be at -2, and that's where my first point is going to go. Okay, remember the parent graph starts high, then halfway it's going to be at its lowest point. Well, the lowest point has to be that same amplitude, which is 4, so I need to be 4 below the midline. Again, this is your midline here. So I want to be 4 below that midway at the halfway point. So at 2 pi, I'm going to be 4 below -6, which means I need to be down at -10. So let me extend my graph a little bit. -8 is here, -10 is 2 below that. That's where my lowest point is going to be. And then my cosine period finishes up at the top again. Well, the top is at -2. That's going to be at that end. My end location is at 4 pi. So at 4 pi, I should be back up at -2 again. And then what do I do with these intermediate points in between? Well, that's where they cross the midline. So halfway in between 0 and 2 pi, I should be crossing the midline, which is at -6. And then halfway between 2 pi and 4 pi, I should be crossing the midline again, right at 3 pi. So now I have 5 points on my graph. Now I can sketch in what my graph looks like, just following the pattern of the cosine parent. So we've got this little curve going down, approaching the bottom point, approaching the midline. That one got off a little bit. So it's approaching the midline again, and then coming back up and approaching 4 pi. Now the last thing that I need to do, I've used my amplitude, I've used my period, and I've used my vertical shift, which gave me my midline. Last thing I need to do is to employ my phase shift. The phase shift says that I need to go -2 pi. Well, negative implies that I'm going to go to the left. So we're going to take this entire graph and we're going to move it 2 pi to the left. So where this point at 4 pi is, if I move that 2 pi to the left, that new point is going to be at 2 pi. Okay? I'm just moving each one of the points that I've already graphed 2 pi to the left. So now I do the same thing with this little red point right here. If I move it 2 pi to the left, it's going to end up right on top of this red point here. Take the bottom point, move it 2 pi to the left, which is going to put it right on the y-axis. So each time I'm just shifting it over 2 pi to the left. Again, I take this point that's on the midline, move it 2 pi to the left. So I'm now over at negative pi. And then finally I move my first point that's on the y-axis 2 pi to the left, and it will end up over at negative 2 pi. Once I have employed the phase shift, now I'm ready to graph my entire function with its phase shift. And when I'm graphing the actual function, I go ahead and use a solid curve instead of a dotted one to represent that it's the real function. And once you've got where your initial function is, you can add in a little bit of extra to show that it continues on forever. Okay, so this is your graph. Go ahead and pause, finish copying it. We'll do one more example. Okay, example number 2. We want to state the amplitude period, phase shift, and vertical shift for f of x equals negative sine of x minus pi plus 1. So the first thing we're going to do is label our parts. A is equal to negative 1. B is equal to positive 1 in front of the x. C is equal to pi, and D is equal to positive 1. Now, once I've labeled those, now I'm ready for my amplitude. Amplitude is the absolute value of A, so we're doing the absolute value of negative 1, which is positive 1. So our amplitude is 1. Period is equal to 2 pi divided by B. So 2 pi divided by 1 is equal to 2 pi. So the period of our function has a length of 2 pi. Phase shift is C divided by B. This one's a little bit easier because I've just got pi divided by 1, which is pi. So our phase shift is going to be a positive pi, which means we're going to the right pi. And finally, we've got our vertical shift, which is D. And on this, our D is equal to 1. So we're going to be going up 1, which also means that our midline is located at y equals 1. Let's go ahead and pause and write down this information, and we will finish up with our graph. So let's go ahead and draw our graph now. We want it to have a period of 2 pi, so I'm going to start off with 2 pi, and I'm going to divide that into 4 parts. Cut it in half, that's where pi is located. Cut that in half, I got pi over 2, and then cut in the little portion between pi and 2 pi, and that's 3 pi over 2. Now, once I've done that, now I'm going to draw my midline. My midline is located at y equals 1. So y equals 1, I draw in my horizontal dotted line to represent the midline. Now I'm going to start graphing the initial function before I do the phase shift. We have an amplitude of 1, so I want remember this is the sine graph, so on your parent of your sine, the parent starts at 0, 0. We're shifting up, so we're going to start at 0, 1. We want it to have an amplitude of 1. So notice on your sine graph that you have 3 points that are on the midline. You have the first point, the midpoint, and the end point. So I'm going to have 3 points on my midline because it's the sine graph. So the first point, the middle point, and the end point are all on the midline. And then your amplitude is going to be a height or a depth of 1 above or below the midline. Now, go back and remember that our A was equal to -1. Because A was equal to -1, anytime that A is negative, that means that we have a reflection. So instead of going up first on my sine wave, I'm going to go down first. So my first point is going to be down instead of up above for the amplitude. So I'm going down 1 for the amplitude, which means my next point that I'm going to put over here between at 3 pi over 2 is going to be above. So this one's just kind of doing the backwards of the sine wave because it was reflected. That's what the -1 tells us to do. So it flips it upside down. Okay, once I've got that point on there, I'm now going to sketch dotted line, because this is not my final graph, just kind of sketching what it looks like. And then the last thing I need to do is my phase shift, which tells me to move it pi to the right. So I want to take each one of these points and I want to move them pi to the right. So I'm going to start with the first point. If I move it pi to the right, it ends up in the same, it's going to land on top of the point that's at pi. Okay, so I'm going right pi. Now I'm going to take my next point and I'm going to move it pi to the right. So if I move it the same amount, pi to the right, it's going to end up over here at 3 pi over 2. So I have one point here, I have my next point here. Now I go to my third point. When I move it pi to the right, it's going to end up on top of the point at 2 pi. Go to my fourth point and I move it pi to the right. So it's going to end up at 5 pi over 2. Same height. And then I'm going to take my last point and move it pi to the right. And it's going to end up at 3 pi. So I've now translated my entire graph pi to the right. So now I can go ahead and connect these. Now this is my real graph, so I'm going to connect it using a solid curve. And once I see what the pattern of that is, I just continue drawing it out. And so you'll notice that it took the entire graph and it just slid it over a distance of pi to the right. Still has the same shape to it, it's just starting and ending at a different place. So finish copying this in your notes and we will see you tomorrow.